Hello, pre-calculus. This is day 2 of section 2.1. Just continuing the notes from last class. Today we're going to do finding x-intercepts, y-intercepts, complete the square, writing equations, bunch of stuff. But we're just talking about quadratics still, so parabolas. First of all, how many x-intercepts are possible? Since the degree of the quadratic is 2, then the number of solutions possible, or the number of x-intercepts possible, is a maximum of 2. So I could have a graph, and I could have a parabola that opens up, passes through 2 times on the x-axis. I could have a different parabola on the same graph that opens downward and passes twice through the x-axis. So there's an example of 2 solutions. But there are other cases. If we have a parabola that the vertex is on the x-axis, the parabola kind of bounces off that x-axis. It's tangent to the x-axis. Here's another example. Tangent to the x-axis. Then we would have just one x-intercept. And then there is a third scenario where we have a parabola that maybe opens down, but the vertex is below the x-axis. Or maybe we have a parabola that opens up and the vertex is above the x-axis. In this case, we would have 0 solutions, or 0 x-intercepts. So the next section is finding our x-intercepts, and we're going to find y-intercepts. And there's 3 different methods that I'm going to go through. Now, some of these methods work all the time. Some of them are just convenient in certain times. I'm going to show you each of the methods. So the first method is called square roots, and I have / completing the square. If you do not remember completing the square from Algebra 2, we are going to review that just below this example. But if you do complete the square, you can do this always. It always works. On quadratic equations. And what it does is it rewrites the equation in vertex form. If it's in vertex form already, we would just use square roots. If it's not in vertex form, we can use completing the square to put it into vertex form. So I'm going to do question A using this first example of square roots. So this is already in vertex form. To find, let's start with the x-intercepts. To find the x-intercepts, we need to make y equal to 0. And in this equation, y is the same thing as f of x. So I'm going to start by replacing f of x with 0. And then what I'm going to do is I'm going to peel away those layers until I can get x by itself. I'm going to isolate x. So add 8 to both sides. Then I'm going to divide by 2. At this step, I need to get rid of the square root symbol. The square symbol. And I'm going to do that by using square root. If you do the square root, you have to have that plus minus because there's going to be 2 solutions. And then finally, we'll add 3. So I get x is 3 plus or minus 2. Now I have to find the x-intercepts, and this is not in a form that says x-intercepts. Plus, I can add together 3 and 2 or subtract 3 and 2. So I'm going to go ahead and make my first x 3 minus 2, which is 1. And my second x, I will make 3 plus 2, which is 5. And then we're going to write them as x-intercepts, which are ordered pairs. 1, 0, 5, 0. You will see that I wrote them from smallest to greatest, or lowest to least to greatest. I don't know what I'm saying. Smallest to biggest. I put them in order from left to right. And then I wrote them as a collection of solutions in the fancy brackets. So that would be our x-intercepts. We're also asked to find our y-intercept. And to find the y-intercept, we make x equals 0. So I'm going to take my equation and I'm going to make x equals 0. So I start with f of 0 equals 2 parentheses 0 minus 3 squared. Is it plus 8? I already forgot. Oh, minus 8. Minus 8. Now we're just going to evaluate this for f of 0. So 2 times negative 3 squared minus 8. It's 2 times 9 minus 8, which is 18 minus 8, which is 10. So our y-intercept is 0, 10. Again, writing it as an ordered pair because we're asking for the intercept. All right. So that was our first method. The next example, I notice it's in like a quadratic form. The first thing I would do would be see if I can factor this. If it starts with x squared, it's got to be an x and an x. That minus sign and then the plus sign means both have to be minus. The 1 has to be 1 and 1, but when I check it, there's no way that we can equal 4 in the middle. This is not factorable, so I cannot use factoring here. So I could take this and write it in vertex form using complete the square, which I haven't showed you yet. So instead, I'm going to show you a different method, which is quadratic formula. Now, quadratic formula is easy to remember. We have done quadratic formula already this year. I've already embarrassed myself enough by singing it, so I'm just going to sing it again. So the song helps you remember it. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. All right, I'll take autographs later. Okay, so we are going to use the quadratic formula to find the x-intercepts of question B. So x equals opposite b, so it's negative 4. I'm going to put positive 4. Plus or minus square root b squared is going to be 16 minus 4ac all over 2a. There we go. So we've got it put into quadratic formula. So x is going to equal 4 plus or minus. That's going to be the square root of 12 over 2. Now, when we have quadratic formula, we want to always check to see if we can simplify the square root any further, which we can. So 4 plus or minus 2 square root 3 over 2. And then what we're going to do is we're going to see if there's any number that we can factor out. Of the numerator and cancel that with a number that we could factor out in the denominator. And I noticed that 4 and 2 are both divisible by 2. So I am going to factor out a 2 from the top, and I will get 2 plus or minus square root 3 left over. And in the bottom, I also factor out a 2, and I get 2 times 1. If you have factored them out of the top and the bottom, you are allowed to cancel. Only if you factored them. So we have that x equals 2 plus or minus square root 3. And we're going to write this as x-intercepts. There's 2 of them. My first one can be 2 minus square root 3 comma 0 My second one is going to be 2 plus square root 3 comma 0. You notice I keep going with the minus first, which is weird, but that's because I'm going from left to right. I'm going from small to big. I'm putting them in order. So that's why I keep using the minus first. All right, the y-intercepts. We are going to make x 0. So we have f of 0 equals 0 squared minus 4 times 0 plus 1, and that equals 1. So our y-intercept would be 0, 1. Okay, so that was quadratic formula. And then question C, I'm going to try factoring this one again. Okay, x and x. This minus sign tells me we're going to have 1 plus and 1 minus. And factors of 56, 7 and 8. So I'm going to put a 7 here and an 8 here, and I'm just going to double check. When I multiply this together, I get negative 8x. When I multiply this together, I get positive 7x. And those do add up to equal that minus 1x in the middle. So I know I have factored it correctly. So to find the x-intercepts when it is in factored form, we're going to make the y 0. And all we have to do is set each factor equal to 0, just like we were doing in trig. And so I get 2 x-intercepts. Well, I get 2 zeros, and now I have to write those as x-intercepts. So I'll take the smaller one first, which is negative 7, and then 8. Okay, we also have to find the y-intercept. And to find the y-intercept, you could use the factored form or you could use the original form. It doesn't matter which form you use. I'm going to choose the original form because it's much easier for me. In my opinion, it's easier to plug it in that one, but it doesn't matter which one you use. So I'm going to do f of 0 equals 0 squared minus 0 minus 56. So I get negative 56. 0, negative 56. On your assignment, you're going to have to graph some quadratics, and along with the graphs, you're going to find x and y intercepts, the vertex, and the axis of symmetry. One thing that I just want you to be aware of is when you graph, think about, the values that you get so that you know how big to make your scale. If I was graphing this last one here, I need to have at least negative 56. So maybe I count by 20s. No, not 20 there, but maybe I count by 20s. Maybe I count by, I don't know, 10s. And I mean, there's more. I gave you guys graph paper, so there's like 10 little things here. So maybe I count by 10s. And so we can just approximate where that negative 56 would be. You can count your x-axis by 1 and then count your y-axis by 10s if you want. It doesn't have to be the same. Just make sure that I know what you're counting by labeling it. Okay, so the next section is using complete the square. Excuse me. So complete the square. This is an algebra 2 concept, and it just puts this equation into vertex form. So what I'm going to do first is I am going to rewrite this as f of x. I am going to add 5 to both sides. And then I'm going to leave a space. X squared minus 4x. Okay, now in that space, I'm going to put a square. And I always use a square because we are completing the square. So it helps me remember that that's what goes in that spot. It does not have to be a square. That's just what I do to just like help me remember. Now to find out what goes in that square, we go to the side with the x squared minus 4x on it. And we use our middle value of -4, which is our b. And we have a formula. It is b divided by 2 squared. So I'm going to do b divided by 2 squared, which is -4 divided by 2 squared, which is -2 squared, which is 4. And 4 goes in the square. But if you add it to one side, you have to add it to the other. The next thing that we're doing is we're going to rewrite the left side as f of x plus 9. And then on the right side, we're going to factor. But what we have done by using b over 2 squared is we've made this into a perfect square trinomial. So when we factor this perfect square trinomial, it will be something squared every single time. As long as you've done the work correctly, it'll be something squared. It'll always be that x in front, and then the last number will be whatever this number was before the squaring. So just the b over 2 before you squared it, that's going to be the number that goes here, -2. Then the last step, I'm just going to subtract 9 from both sides. F of x equals x minus 2 squared minus 9. And this is vertex form. So it really was only about 3 steps to take an equation that is in quadratic form to put it into vertex form. And this is basic. They get a little bit more challenging. So here's another example that's a little bit more challenging. I'm going to start it out the same way. I am going to move the 8 over, and we're going to rewrite this as g of x minus 8, I'm going to leave a space, equals -x squared plus 3x. And then what I'm going to do is I'm going to put that square in. But we have a problem because complete the square only works if the coefficient in front of the x is 1. So -1, you can't complete the square with. So we're going to manipulate this a little bit. And what I'm going to do is I'm going to factor out that -1 from the -x squared and the 3x. So I'm going to factor out that -1. I'm also going to factor it out of the square, but I don't know what number that is. So I'm just leaving it blank for now. All right, so my next step would be like g of x minus 8 plus something that I don't know yet equals, now I'm taking out that -1, and I have left over x squared minus 3x. Now, I do not have a square anymore. I have a square divided by -1. So you can write it however you want it. I like to just make it a fluffy cloud because there's a number there, but it is not the same number as the square because it's whatever the square is divided by -1. That's what the fluffy cloud is. So I'm going to complete the square and put a number in fluffy cloud, but then I have to multiply it by -1 before I put it back into the square. So that's the difference here. So I'm going to use that formula that says b over 2 squared So I've got negative 3 over 2 squared. Now, I would highly suggest with fractions that we leave them as fractions and not pull out our calculator. We just square a fraction by squaring the top and squaring the bottom separately. So 9 over 4. So that's what's going to go in the fluffy cloud. But that's not what's going to go in the square. To go in the square, we have to multiply back the negative 1. So what's going to go in the square is 9/4 times negative 1. So negative 9/4. So that means on the other side, negative 9/4. Now, the only reason I multiplied them back was to figure out what went in the red square. After that, after that step, I do not need this step anymore. I'm not going to go back to that. I'm going to move on from where we were last. So here I've got g of x. I'm going to subtract 8 and subtract 9/4 more. So maybe I change my 8 into 32/4 and subtract 9/4. So what do I get? Negative 41/4 equals, and then on the other side, we've got negative. And then I get to factor, because it's a perfect square. I'm going to factor this. It's going to be x, and then whatever was in here before squaring it goes right here, minus 3/2 squared. And then finally, I'm going to add 41/4 to both sides. And we will have our equation in vertex form. Anytime it's in vertex form, you can find the x-intercepts by plugging in 0 for g of x and solving for x using square roots. There's one more. So we'll work this one out. Let's see. First thing, subtract the 7. Rewrite it as f of x minus 7, leave a space, equals 2x squared plus 8x. And that's where I'm going to put my square. I cannot complete the square if there is a number here. Other than 1. So I must factor. So we're going to factor out the 2. But it's not disappearing. I'm only doing it on one side. So now I've got f of x minus 7 plus square equals, now we factored out that 2, and I have left over x squared plus 4x plus, and I do not know what box divided by 2 is, so I'll just make a different shape. Fluffy cloud. Okay, my next step is to do b divided by 2 squared, so I can fill in the fluffy cloud. So 4 divided by 2 squared is 2 squared, which is 4. But 4 does not go in the red box. Because we took 2 out of the red box and got 4, we have to put it back in. So I'm going to have to take 4 and multiply it by 2, and then I get 8. So 8 is what goes in the other side of the equation. So now on the other side, we've got f of x plus 1 equals 2. And now I'm going to factor x plus 2 squared. Subtract the 1, f of x equals 2. x plus 2 squared minus 1. And we have vertex form. Okay. The last section is writing equations of a parabola given the vertex and another point on the parabola. And then there's, the next example is, I don't think you have the vertex. Yeah. All right. So to do this, we are going to think about our vertex being HK. And we're going to think about our ordered pair as being XY. And when you look at HK, XY, this would be like Y. Every single variable up here gets filled in except A. So what we have to do is we have to fill everything in. So Y is 0. We do not know A. X is 0 minus H is 1 squared plus K is 2. And now we're going to solve for A. So I'll get 0 equals A times negative 1 squared plus 2. Move the 2 over. And then negative 1 squared is just 1. So A is negative 2. So after we solve for A, then we just write vertex form with the H, K, and A values filled in. So we'll have f of x equals my A value, negative 2, x minus H squared plus K. Okay, and then we've got it in vertex form. Do one more of those examples. Here we have a vertex that is 4, negative 1. That's our HK. And it passes through the point 2, 3. And since I can't see my vertex form anymore, I'll go ahead and rewrite it. Y equals A times x minus H squared plus K. And then we'll plug in Y is 3. I don't know A. X is 2. H is 4 squared plus K is negative 1. And we're going to solve for A. So I'm going to add the 1 and square the negative 2. And so it looks like A is equal to 1. So then we'll go ahead and write our vertex form. F of x equals, now since A is 1, I'm not going to write it. I'm just going to, leave it empty because we should know that there is a 1 there. And then we put x minus H, which is 4, squared plus K, which is minus 1. And that's our vertex form. All right, the very last example, find 2 quadratic functions, one that opens upward, one that opens downward, whose graph has the following x-intercepts. So if I'm given the x-intercepts, I can write these as zeros, which I'm going to write x equals negative 5 and x equals 5. And from there, x2, sorry. And then from there, I can make them into factors. And I can make them into factors by making them equal 0. So I'm going to add 5 to this one. X plus 5 equals 0. And I'm going to subtract 5 to get x minus 5 equals 0. So we're kind of going backwards of how we found the x-intercepts, and we're putting them back into an equation. So once these are equal to 0, now we write them as factors as part of the equation. Now, this says we have to do 2 functions, though. Here's one of them. And I believe in the assignment, it asks you to write it in quadratic form, which is ax squared plus bx plus c. So I'm going to go ahead and FOIL this out. And so that's going to give me f of x, I didn't leave myself enough space, f of x equals x squared minus 25 when I multiply that out. Okay, but we also have to have one that opens downward. And to open downward, we're going to need a negative on the outside for our a value. So when I do my FOIL, that does not involve the negative sign at all. So after I do the FOIL, all I have to do is multiply both terms that I got from doing FOIL by the negative sign. So I'm going to have negative x squared plus 25 for the second equation. Now, it says that you can do any equation that you want at all. So you can put numbers up front other than 1 and -1. You can use 200 and -42 if you want. But I am just going to do 1 and -1 because that is the shortest way. All right, this last one, this one's a little bit special. And it's going to really be important for what else we are doing in this whole chapter. So the first thing I'm going to do is I'm going to write each of these as x equals. Now this one's easy. I'm going to move the 2 over and get x minus 2 equals 0. And so we get a factor of x minus 2. This one's a little bit more challenging. We will not want a fraction. So I'm going to multiply both sides by 2 first so that I can cancel out the fraction. And I'm going to get 2x equals -5. Then I'm going to add the 5 over. 2x plus 5 equals 0. And so my factor for this one will be 2x plus 5. So one of our equations, how about I just put plus or minus 2x plus 5 and x minus 2, because I have to multiply them out anyway, so that's not my final answer. So one of the equations, when I multiply it out, I'm going to get 2x squared. My outside is going to be minus 4x. My inside will be 5x, which adds together to give us positive x. And then last is -10. So that will be my positive version. And then my negative one, the one that opens down, after I get this answer, I'm just going to distribute the negative sign. So f of x equals -2x squared minus x plus 10. So all the signs switch. All right, it was a lot of information, but it's really just half a section, and it's basically a review from Algebra 2. If you have questions, definitely ask. I want you to have a good foundation before we start adding on more powers and doing all kinds of crazy polynomials, which is so fun. Have a wonderful day. Talk to you soon.